Determine the angle in standard position in radians in the interval from 0 to 2 pi that passes through the given point. Give the exact value. So because we're told to give the exact value, we will not be using the calculator because the calculator will not give angles in terms of pi. The first point is 2, 2 square root 3. Let's plot this on the coordinate plane. It doesn't have to be exact, but 2, 2 square root 3 would be approximately here, which means we're looking for the angle with the initial side along the positive x-axis and the terminal side passing through the given point, which is this angle here. Recall that tangent theta is equal to y divided by x, which indicates theta is equal to inverse tangent of y divided by x. And therefore, for number 1, theta must equal inverse tangent of, again, y divided by x, which is 2 square root 3 divided by 2, which if we simplify, we can write as inverse tangent of square root 3 divided by 1. Having a tangent function value of square root 3 divided by 1 should remind us of a 30, 60, 90 reference triangle shown below in radians, where notice the tangent of pi divided by 3 radians is equal to the ratio of the opposite side to the adjacent side, or square root 3 divided by 1. And because pi divided by 3 is in the first quadrant, pi divided by 3 is the angle we're looking for, passing through the point 2, 2 square root 3. If we wanted to sketch a reference triangle for this angle, we would label the short leg 1, the hypotenuse 2, the long leg square root 3, and notice the tangent function value is square root 3 divided by 1. So the exact value is pi divided by 3 radians. For number 2, the point is negative 4, 4 square root 3, which would be in the second quadrant. Let's just say approximately here. This would be negative 4, 4 square root 3, which indicates we're looking for this angle in standard position. This indicates that theta is equal to inverse tangent of y divided by x, which is 4 square root 3 divided by negative 4. Simplifying, we have inverse tangent of square root 3 divided by negative 1. Ignoring the sign for a moment, we already know that tangent of pi divided by 3 radians is equal to square root 3 divided by 1. This is not the angle we're looking for, but pi divided by 3 is the reference angle in the second quadrant, which is this angle here. Notice if we sketched a reference triangle, we would have negative 1 to square root 3. The reference triangle does give a tangent function value of square root 3 divided by negative 1, which indicates the angle theta we're looking for is equal to pi minus pi divided by 3 radians, which is equal to 2/3 pi radians. So it is important to always make sure the angle is in the correct quadrant as well as in the given interval. Number 3, the point is 3 square root 3, negative 3, which is in the fourth quadrant. Let's say approximately here. And because we're looking for an angle from 0 to 2 pi radians, this is the initial side, this is the terminal side, and we have rotation counterclockwise. So this is the angle theta we're looking for. We also know that theta equals inverse tangent of y divided by x, which is now negative 3 divided by 3 square root 3. Simplifying, we have inverse tangent of negative 1 divided by square root 3. Again, ignoring the sign for a moment, this should once again remind us of a 30, 60, 90 reference triangle shown here on the left in radians. Notice the tangent of pi divided by 6 radians equals 1 divided by square root 3, which means pi divided by 6 is the reference angle in the fourth quadrant, which is this angle here. From here, we should be able to recognize this indicates the angle theta we're looking for is equal to 2 pi minus pi divided by 6 radians. So 2 pi minus, let's say, 1/6 pi, and we know that 2 pi is equal to 12/6 pi, So 12/6 pi minus 1/6 pi is 11/6 pi. The angle in standard position passing through the point 3 square root 3 comma negative 3 in the interval from 0 to 2 pi radians is 11/6 pi radians. Notice if we did sketch a reference triangle for this angle, we would label the short leg -1, the hypotenuse 2, and the long leg square root 3, which does give us a tangent function value of -1 divided by square root 3. And for number 4, we have the point -1 comma -1, which is in the third quadrant, approximately here, let's say. And therefore we're looking for this angle in the standard position. We know theta equals inverse tangent of -1 divided by -1, which simplifies to inverse tangent of 1 divided by 1. It's always helpful to leave the tangent function values as ratios. Having a tangent function value of 1 divided by 1, or simply 1, should remind us of a 45, 45, 90 reference triangle shown here in radians, where the tangent of pi divided by 4 radians equals the ratio of the opposite side to the adjacent side, or 1 divided by 1. But of course, pi divided by 4 is not in the third quadrant, it's in the first quadrant, but pi divided by 4 is the reference angle in the third quadrant, which is this acute angle here. And therefore the angle theta that we're looking for is equal to pi radians plus, let's say, 1/4 pi radians, which is the same as 4/4 pi plus 1/4 pi, which is 5/4 pi radians. And just to verify, if we did sketch the reference triangle for this angle, it would look something like this. We'd have -1, -1, square root 2, and notice the tangent function value is -1 divided by -1, which of course simplifies to 1. I hope you found this helpful.